Hello viewers, in this tutorial I will show you how to apply a transient thermal conduction in an Ansys software. So let's see, there is one problem statement and here is a figure. So I'll read this problem statement. A block assumed to be infinity long, so distance is infinity, and the properties of the material is given below. So first property is a thermal conductivity, then heat capacity and density of the material. So here is the value 54 watt per meter Kelvin, then 0.49 kilojoule per kg Kelvin, and density is 7850 kg meter cube. So all properties are given, and initial temperature is 50 Kelvin and maximum temperature is 500 Kelvin. Okay, so let's start. Open Ansys, go to preferences. So preference is a thermal, then go to preprocessor, element type, add edit delete, add solid quad 4 node 55. So this is the plain 55. Then close, material property, material model, go to thermal, conductivity, isotropic. So there is a 54. Okay, then click on a specific heat. So specific heat is a 0.49. So let's put here 0.49. Then click on OK. Go to density. So density is a 7850. Then click on OK. Then go to material and exit. So all material property I have to put here, and then go to modeling. So first go to create area, and by rectangle by two corners. So let's assume this rectangle is a size 2 meter by 2 meter. So 2 meter by 2 meter. Then okay, so let's area is a become. Then click on meshing, mesh tool, area, set, select, okay. Then 0.05, click on OK. Go to raise hidden, click on a mesh, select area and OK. So meshing is done now. Raise hidden, and this pop-up window we have to close now. Okay, then I will go to define a solution type. So go to solution, analysis type, new analysis. So there is a transient thermal conduction, not a steady state. So you have to use a transient, then OK, then a full, OK. Go to solution control. Okay, then solution control, in that we have to decide how much load step we have to require and how much iteration we have to find out the total time dependency with respect to temperature. So go to first time at the load step. Okay, so this is a basic general we have to basic general load step and maximum load step we have to put here. So first option is a basic. In that basic, okay, so in that basic, go to time at the end load step. So I will put here a time is suppose 5 minutes and suppose 6 minutes. So 360 second. Okay, 360, 60 multiply 60 and 60 multiply 6. Okay, now go to automatic time stepping. So automatic time stepping here is on. Then number of sub step, there is a minimum 20. Then maximum number of steps, there is a 150, and minimum number of sub step, there is also 20. Okay, then frequency we have to write every nth step or nth sub step. After that basic, go to non-linear, and in a non-linear, first value is a line search, so is on. Then number of maximum iteration, so we have to number of iteration is suppose 50. I will choose a minimum iteration. If you use a maximum iteration, so you can find out the exact or accurate value. So I will put here a minimum. Okay, because I would calculate a less number of iterations. Okay, so click on OK. So solution control is done now. Then now I have to go to apply constraint. So click on a define load, then apply, then thermal, and here is the boundary condition means constraint, nothing but the temperature. So click on a temperature, then on a node. Okay, so click on a box, so select bottom line. So okay, and this is the value nothing but the 50. Then apply, click on box and topmost side, then click on OK. This value is the 500 Kelvin, then OK. So see here yellow region is a shows, so yellow means there is a constraint is apply or constraint is temperature. So go to solve current load step, OK, and wait. Solution is done now. So close this, also close this, and go to general post processing, plot result, control plot, nodal solution, degree of freedom solution, nodal temperature, and OK. So this is a contour band. Okay, so if you want suppose this minimum number of contour, so go to plot control, then style, contour, uniform, and I will choose here only 6 contours. So see here there is only 6 contours, there is a 6 color bands. So minimum is the blue color means 50 Kelvin, and maximum is the red color nothing but the 500 Kelvin. If you want more accurate, so go to again style, plot control, style, contour, and uniform, number of contours is 8 suppose, and user specified, click on OK. So this is the 8 number of contours. Then go to list result and element solution, nodal solution, degree of freedom solution, nodal temperature, OK. So you have to see here there is a each and every node how much temperature is the value. So see here node number suppose 313 is a 455, there are 314, 466. So each and every number of load step there is a each and every node we have to temperature is given. Okay, so after that list result, go to time hist post processing. Okay, so click on this, and I will choose here is a graph. Okay, so click on this plus sign, add data, degree of freedom solution, nodal temperature, and variable name is suppose. If you want suppose you have to use suppose calculation is a 1 suppose, and okay, so a new pop-up window is open, and this asks node for a data. So I will choose suppose enter this geometry, I will choose suppose this node and calculate this node how much temperature and what is the actual graph is the rises with respect to time. So click on this. Okay, see here this calculation window is add here, or this is a variable is add here. So minimum value is the 139 and maximum is the 353. So this is a temperature range. So click on this graph data. Okay, so see here this graph is started from 0 to 400 total time. Okay, so maximum time is 0 to 360. Okay, so this is 6 minute, and temperature rises from 125 region to above 350. So this value, okay, so this graph is I have to again convert variable names or axis name. So axis label how to change. So how to change the axis label, go to plot control, style, graph, and modify axis. So first one is time in a second, and second one is a y label, there is a temperature in a Kelvin. Okay, then click on OK. Okay, so after that again we have to go to time hist post processing, then click on this calculation and graph. Okay, so click on this. So temperature in Kelvin and time in a second. So go to report generator, append, click on, and there is graph you have to capture from here. Okay, so this is the transient thermal heat conduction with respect to time. Okay, thank you.